Busy, I think. Well, I think it And I'm done. Like, come up with crabs. Come on, take a seat. There's more chairs. Jess, take a seat. You've been called out.
Okay. Yeah. It is YouTube live. Yeah.
Okay, thanks everyone for coming tonight. It's a very exciting time in the blockchain crypto space. It's the crypto winter, and nevertheless, some nerds turn up. So, this is the reignition of the Ethereum Sydney meetup that has been going on for quite a few years with Nicholas and Boki is here, and we have a number of other core organizers that are not here and hopefully will be next time. So yeah, quite exciting to reboot it, and we have yeah, some familiar faces from a few years ago, some new faces, which is always good. And for the agenda, we will have initially Nicholas will cover the evolution of Uniswap, which I'm sure that everyone here would know is the biggest decentralized exchange out there. That has been evolved from the pioneer of AMM to something very generalized and exciting that Nick will tell us about all the technical details. Then we'll do some community shout outs. So if someone wants to share something very urgently that they think is important to let us know, like who is Satoshi or how much Bitcoin will be worth a few years from now, after that, let us know. And then Boki is the nerd in there, and he's going to do some live coding session to cover the ChadX, Chad from Chad. It's the antithesis to the, I won't mention the word. And ChadX is the on-chain order book, super exciting, red, black, something that we'll hear more about. And yeah, then a little bit more shout outs because there's always exciting stuff to share. And then we'll have to like force you out because we don't want you to be networking and having fun. You have to like go and sleep. So yeah.
Cool. Good start. Yeah, so Nick Addison, yeah, developer, smart contract developer. Yeah, when Daniel asked me to give me a technical talk, I happened to be looking at Uniswap at the time, so I said, oh, okay, I'll talk about Uniswap. I don't actually work for Uniswap. I work for Origin Protocol now, but that's topic for another day. Yeah, when I was, yeah, we were looking at doing some, I've done numerous integrations with Uniswap, but I was sort of going back over some of the older versions, and the way, so the under the hoods of Uniswap is actually quite interesting from a technical perspective. If you're a beginner to crypto or Ethereum, apologies, this is going to be this is pretty technical, but hopefully you might get some stuff out of it. Okay, let's work. Okay, so let me move that. So first of all, I just want to talk about like the general common pattern in DeFi about how a swap would work, and then we'll go through and see how Uniswap differs to the typical pattern. So these are sequence diagrams. My IT career is littered with sequence diagrams. Basically, like communication between different parties and time goes down. So typically, I'm going to make a big assumption everyone knows what a token is. So you own a token, you can transfer a token. You can transfer a token to someone, or you can transfer it from someone. If you're transferring it from someone, you've got to give them approval. So in this particular case here, we have a user who wants to do a swap on this generic DeFi swap contract, some sort of pool. They want to swap token A for token B. So they need to call token A to say, okay, I want to give the swap contract approval to transfer a certain amount. Then they call the swap contract and say, I want to do the swap. I want to swap A and B for this, this amount, this amount of A tokens. Now the important bit here is that the typical pattern is a swap contract will then transfer from the user. So it's like a pull. It'll pull the tokens, it'll pull those A tokens from the user. So if you're swapping A tokens for, if I'm the swap contract and runs the person swapping, he gives me the A token and I give him back the B token. So that's what these two transfers is. Transfer from the A token from Ron, and then I give Ron the B token. So that's the typical DeFi pattern, which Uniswap doesn't necessarily follow. Okay, it's not working. Okay, so yeah, we're up to well, is Uniswap up to version 3, version 4 white paper got published last week or the week before. Yeah, I'll just sort of go through. I'll sort of go through how each of the different versions work, and you'll see how these token transfers differ. So Uniswap is an automated market maker. It uses a constant product. AMM is automated market maker. So it's the classic X times Y equals K, where X and Y is the balance of the pool. So it always equals some constant. So as the balance in the pool change, the price changes. I won't talk about that. There's plenty of literature. And Uniswap's actually got quite good literature about how that works. And there's, you're studying that area, like there's a whole heap of different AMMs and different models. I'm not talking about that. I'm going to talk about token transfers. Version 1, it was each pool had a ERC20 token, so like a USDC token, and it was paired with just native ETH. So so you had like a USDC pool, and it had USDC token in it and native ETH. It could do swaps between tokens. So we'll go through how that you could chain a number of swaps together. We'll go through how that works. This is from their like early version. You can transfer to a different. You can swap. So in this Ron example, Ron could say, I want to swap token A for B, but I want to give B to Bocky. So you can specify the recipient of where it goes. It's fairly straightforward to do, but at the time that was pretty advanced. And when I say at the time, this was only what I think they launched in November 2018. I think so. It's like 5 years ago. You got a liquidity provider token, LP token. So when you deposit your liquidity into the pool, you got a token which was like a receipt basically, and that's your claim on the assets. And there was a flat 0.3% or 30 basis points fee on the swaps on the pool. Okay, let's get into the more interesting bits. So the contracts are written in Viper, which is a smart contract language, very similar to Python. They had immutable proxies. So now we're starting to get into the technical details now. So effectively there was 2 contracts. If you look in the version 1 repo, there's 2 contracts. There's an exchange contract and a factory contract. The factory contract creates these proxy contracts, and these are very. You actually look at the bytecode on it, like these are tiny. All they're doing is any calls coming in, they're redirecting the logic to the exchange contract, and that's through a delegate call. And we'll go through a little bit more of that in a minute. But yeah, so you've got these and unlike a lot of the proxy contracts in the DeFi space, which are upgradable, which basically means you can do whatever the hell you like with them. So they're not immutable. These are immutable. You can't change those. These were created using the create opcode, which is important because it means it's non-deterministic. And yes, the other thing, because it's non-deterministic, the factory here, which creates these proxies, was actually a registry as well. And I'll see a little bit example very soon. But basically, when I say registry, it's a registry of like USDC is this particular proxy contract, the address. It's just a mapping of the asset or the token to the particular proxy contract. Okay, so these are value transfers, so just showing value rather than calls. The next diagram would be calls. So this swap's pretty simple. I probably should have had the diagram the other way around, but these diagrams are generated using a tool I've got called PX2UML, transaction to UML. And I've sort of, well, yeah, these are very basic. So you got this user, this is actually a real transaction from many years ago. So they were swapping 22 US dollars or USDC for F. So at the time, yeah, it was 0.012 F. Notice the order. So so go back to that Ron example. I'm picking a Ron here. So Ron's got the USDC. He's giving me on the swap contract the USDC, and then I give him the F. It actually does it the other way around here. It gives him the F, and then I pull the well. Let's have a look. Let's go through the example. So actually, that is. Do I have the example? Yeah. Here's the USDC. Let me go back. I'll go back. I change the order because it's simpler. I'll do the F swap first. So this one's a simple one. So it's just Ether USDC. So Ron's giving me Ether. I'm giving him the USDC token. Okay. So on version 1, you're calling the proxy contract. This is generated off TX2UML, so it's just the contract calls. F2, you probably can't read that, but it's F2 token input. So you're specifying the amount of F. So the F is when you send an Ethereum transaction, you send the to address, the from address. You include some data, which is basically what function you want to call and the parameters. But you can also specify a quantity or value in there, and that is the amount of Ether you want to send. So here they're sending 0.01 Ether to the contract. Then it's doing this delegate call. So this blue bit means the proxy contract's calling the implementation contract, but it's executing as if it was over here. So in terms of like the storage data, this is just, think of it like a library. It's just like so when the USDC coin gets the balance of, it thinks the caller is this one, not this one. But probably a little detail, probably don't need to get into too much, but the main bit here is the Ether is sending the transaction, and then we've got this transfer call. So the smart contract doing the transfer call to send the USDC back to Ron. So Ron sends me the Ether in the call. I then go and call the USDC to transfer it back to him.
So just to understand, the pool assets sitting in the proxy.
Correct. Pool assets are in the contract because that's where the storage is. I will speed up a little bit and get to ones which are a bit more interesting. Here's an example where we're swapping one token for another. So we're swapping USDC for Matic tokens, doesn't really matter what these are. So the value transfer is Ron sends me the $1 US. I send him a tiny bit of F. Well, actually, I don't send Ron a tiny bit of F. Bob, you can be the Matic pool. So then I send Bob a bit of F, and then he sends the Matic to Ron. So it goes around like that. It's effectively chaining the between the proxy contracts. Let's have a look how that works. You won't be able to see that, but I'll just highlight the key points here. So this is the pool. So I'll be the USDC pool. Ron can be the user. Bob can be the Matic pool. So Ron calls me saying, I've got this one USDC I want to swap. I need to go and call a factory contract to work out where Bob is. I'm going to get the balance. Then I transfer I'm pulling the USDC from Ron to me on the USDC pool. So I've now got the USDC. Through the AMM, we work out the pricing, we'll just ignore that. So we're swapping for amount of Ether. I give the ether to Bob over there. And this is actually done in a call, so there's no like transfer. I'll actually call Bob, and then when I call Bob, I send the ether with it. And I also specify the recipient. I say, when you're done, send it to Ron, which is what that bit there is. So Bob does this bit. He transfers. Well, you've got the ether in the transaction call, so you've got the ether, so then you send it to Ron. So it's done around like that. So that's version 1. I don't think I've got another example. This is getting yeah, you can't see this, but the main point here is that both these contracts here, so that's myself and Bob, we're calling the same exchange contract with a logic. So it's the one exchange contract. Okay, let's go to V2. So V2 got rid of the native F. They're all wrapped ETH. So there was basically 2 ERC20 tokens. They had optional flash loans, which we'll talk about in a minute. They still had an LP token, so a liquidity provider token. They still had a 0.3% fee on the pool. They introduced a protocol fee, which wasn't enabled and has never been enabled, of 0.05%, and that's of the fee. So that's actually never been turned on. Permit support, which I won't talk about, and price oracle, which I won't talk about. The contracts were written in Solidity this time, so not Viper. There was no proxies. So there's still a factory contract, but it actually generates the bytecode for the full contract, so it's not a proxy. They're trying to get gas efficiency. It's using the create 2 opcode, which means it's deterministic, so you know beforehand what those contract addresses are going to be. And it uses a router for orchestration. So instead of like chaining those hops together before, we'll see how the router orchestrates transfers of these tokens. Okay, swapping USDC for F. Sorry, Ron. So Ron's swapping. Well, he's got some more money now. He's got $911 now. It's gone up from the $1. This is probably part of the evolution of these swaps. Got bigger over time. Yeah. Yeah, so this is the value transfer, it's not the calls. So yeah, Ron doesn't actually send it to me directly. We'll go through how that works. Well, let me jump in the next bit. We'll jump in the next bit. Okay, so Ron calls me, so he's saying swap exact token for F. So basically saying, and he's calling this routing contract. So this is doing the orchestration. So Ron isn't talking directly to the USDC pool. So he's saying, I want to swap, he specifies, I want to swap USDC for Ether. It's actually the routing contract. Ignore this bit here, but it goes and says, okay, I'm going to transfer from Ron to me the USDC. So it bypasses the routing contract. Now, what's interesting here as a DeFi transfer node, notice this transfer from Ron to me happens before the actual swap call. So when you actually swap gets called on the V2 contract, it doesn't pull the USDC from it. It's actually got sent before. So basically, anyone could send something to it and then call swap. So this is quite different. And the reason it can do this is because each time a transaction operates, it stores the balance. So when the swap happens, it goes and checks the balance to make sure have I got the USDC. So this is me being this is me over here being a swap contract. I just check, have I got it? I don't care where it came from. I don't care whether it came directly from the user or some other contract or somewhere else. As long as my balance has gone up, so I go and call the USDC contract, check the balance has gone up, then I'm happy with it. And the other thing is it actually sends, well, we've got wrapped ETH in here now. So I'm the one I'm the swap contract. I'll send it back to the router, the wrapped ETH. And then down here, the wrapped ETH is the router doing this orchestration unwraps the ETH. So basically it says withdraw the ETH from the wrapped ETH to get the the native F, we'll send it back to RON. But the key point in here, and the thing which is quite different, is before you call swap, you need to transfer in the asset which is being swapped. That was a big, it's quite a big change from the sort of traditional default stacks. I might, for time purposes, skip over this one because it's just the reverse. I don't think there's anything particularly exciting about that one. Okay, let's do an arbitrage between Uniswap and SushiSwap. Get more interesting. So this example here, so we have some arbitrage contract. So this is, think of that as like the user. They actually get, so they're swapping USDC for RAPD. They actually get the RAPD first. So it's not like they want to swap USD for F. They actually get the F first, and they can do something with it, and then they've just got to give it back later. Then they go and give the RAPD to SushiSwap. We'll send it back to USDC. And then let's see. That's what they just send that proper. Yeah. Okay. So here there's 92 ETH. They've made 0.52 ETH, which is 0.42. Sorry, which is not bad. I'll probably won't go through all this, but okay, yes, okay. The important bit here is we have this Uniswap, we have this callback. So we've called swap. So it actually transfers. So again, we're swapping. So in this case here, so Ron's giving me the USDC. Then ultimately, I'm giving back the RAPD or the ETH to Ron, but I'm actually giving Ron first the RAPD. So so Ron's now this arbitrage contract. This just happened to kick it off. So it's basically a callback function. So so effectively, I'm sending Ron his final output, the RAPD, and then I go and call Ron and say, you go and do whatever you want with that. So in this particular case, it does a swap on SushiSwap. And then as long as that transaction, you have to send me back the USDC. You have to send me back the token. And if you don't, I'm going to kill the transaction. So this is where blockchain power of the blockchain comes in. If I don't get enough balance back, I can just kill the transaction and all this unravels. So all this just reverts back. So that's sort of the power of these flash swaps, which is you're getting the asset and you can go do something with it and then repay it. So think of it as like a loan, like it's effectively like a loan within a transaction. Ron's borrowing some money, doing something with it, and then repaying it all within the one transaction. And if he doesn't repay me, I kill the thing and I never have it. I don't kill Ron. Okay, we're going for time. So we go to version 3 now. Version 3 is quite different, had concentrated liquidity. So instead of depositing money into the pool, you could specify money in a particular range in the pool, so particular price points, which was quite revolutionary. You didn't have a liquidity provider token this time, you had an NFT because it's basically non-fungible. You had multiple swap fees now, so 0.05%, 0.3% and 1%, so depending on the asset class. So yeah, on like US dollar to US dollar tokens, yeah, it's pretty small, tight, so you've got a small fee. And then on 2 asset class, which is completely different, you typically have like a 1%. There was again a protocol fee, which I don't think has ever been turned on. All swaps were flash swaps. So before it was like an optional thing. We'll see in a minute that all the swaps on here are actually flash swaps using a callback. and I will skip those bits. The other difference on the contract, so yeah, here's the solidity again. We've introduced this non-fungible position manager. Basically, it's managing your positions inside, well, they call them ticks basically. So they separate out your liquidity over different price points, and then you can deposit in your liquidity at those particular points. So we've got a contract which manages that. Yeah, again, these are all factory, so there's no proxies. The factory contract generates these, that's same as before. These are just the token contracts. It has a router like before, but it's got a separate quota now. So a separate contract which can quote doing swaps. Swap USDC for it. Okay. I'm going to skip that and go straight to the polls. Okay, so back to the example again. Ron is calling the universal router this time. I'll skip the net. So then this goes and calls swap. So I'll still be the swap contract. So here it's saying, yeah, this is the USDC to F. So again, it's 2 tokens. It's actually wrapped there. I'm actually going to send Ron the RACD before I actually get it from him. And then I'm going to go and do a callback. I'll record the balance before I do this, but I'm going to go call, well, I'm actually calling the routing contract. So this is the concept of the flash swap. So it's like, okay, you can think of this as like a loan. I'm giving out a loan. Then I'm calling you. You can go off and do whatever the hell you like with it. So you can go on arbitrage or do whatever you want. In this particular case, all they're doing is just transferring the USDC in, and then once it returns back, it checks the balances and says, "Did you send me enough USDC? Yes, you have. Good. I'll let this contract go. If you didn't, I'll kill the transaction. Whole thing rolls back." And same thing before. It has to be unwrapped. So the router does the unwrapping. Yeah, so the difference in V3 is this, yeah, all swaps have these callbacks, so they're all flash swaps. But from a user point of view, they don't really see that because they're just talking to the router, which you need because, well, we might test some people here. Why can't a user call the pool directly using your MetaMask wallet? Because your MetaMask wallet isn't a smart contract. So you can't, so when it comes back here and calls this Uniswap V3 swap callback function, if you're just using your normal wallet, which isn't a smart contract, assuming you're not using like a Gnosis safe or something like that, it's not going to work, so the whole thing will fall over. So that's why you need to talk to the router contract. Interesting stuff, eh? Well, I think it's interesting, yes.
So the web interface has what they call a router, which determines the optimum
Yes.
to execute it. That's a different thing.
Yeah, that's different to that. It'd be calling the quota. But yeah, like if you're doing, yeah, if you're hopping between like 2 different tokens, because again, I think actually not all these were ETH based, but yeah, if you're trying to swap one token for another across 2 different pools, it'll work out the optimal route through those pools. Like it might, you might think, oh, it'd be cheaper to go through the pools with the smallest fee, but then the prices might be different. So you might go some pool with a higher fee. Yeah, so that's what the routing is. And then you have DEXs, DEX aggregators like 1inch, which can go do that across multiple protocols. Yep.
In your V1 example, you also have a 3 token route as well.
Yes.
So they have this function from V1.
Yes. Do I have an example? I don't have an example, but yes, yeah, they do. But it's orchestrated through the router, so it does that. Or you can do it directly. So like if you call 1inch, 1inch doesn't actually go through the router. It saves gas, and it actually calls the pools directly. So it handles these callbacks. It does those type of operations.
Yeah, obviously, there's a black box. There's a big risk of the entrance to the class.
Yeah, well,
Just
let,
like this, that's really-
less so with tokens. But yes, like more so if you've got native ETH in there, because when you get transfer the ETH out, that's a call. So yeah, if you're doing anything with ETH,
But, I mean, you're saying that, when I receive.
yes, yeah, true,
the
yeah,
thing
yeah,
in the first place, I get to run whatever I choose.
correct, yes.
Meanwhile,
I mean, yeah, you got
contract call is in a sort of intermediate state.
true, but like it does the balance off beforehand up here, so it knows what it was at the start with. But yes, re-entrancy is an issue. So re-entrancy is when you execute a swap and you give control over someone else, and they can come back. So if you don't do your accounting correctly and don't update your state before you go and call, then they can just keep calling back, and then still steal funds. Particularly if you're doing ETH transfers. And then there's all sorts of like you can even get like read-only re-entry attacks and all sorts of stuff like that. Just out of scope for this talk. Righto, it's getting on a bit, so I will. I think the main point on this one was that even if you're adding liquidity, so this is like meeting a position by the position manager, which effectively means you're meeting here, so you're basically depositing liquidity into the pool. It actually does it through a callback. I don't know what you call it, a flash mint, I don't know. But yeah, that same mechanism I thought was quite interesting, where you call a contract, say I want to add this liquidity, then it goes back to calls you and says, right, it's up to you to transfer it in. So you could go off and do something else. Can't really arbitrage because you're actually just depositing assets in. It's not like you're getting anything back, but you could chain more complex operations up, I guess. So that's the key point in that one. V4. So the paper was out last week or the week before. So the main changes in this are lifecycle hooks. So they're trying to make, Uniswap's trying to make this sort of core library which you can build other things on top of it. So you can put these hooks in when the pool is initialized. You can customize when you're adding or removing liquidity, that's position changes. You can customize the swaps. So you can put a hook in there. So if you're implementing a pool, you can use like the native core Uniswap libraries, and then you can customize and put these your own bits in there. And there's a bit on donate as well. So as an example, so I work for Origin Protocol. We have a rebasing token, which basically means the balance of the token goes up over time as we generate yield, which is different to other tokens where your balance stays the same, but the price of the token goes up. So because our balance is going up, the old Uniswap pools can't handle that. But in theory, well, it should be able to. We've got to do a custom hook and be able to support the rebasing tokens, or at least that's on my to-do list. There is hook management fees. So there's the swap fee, which had before. So that was like at the very first one, it was at 0.3%, and then it had the different ranges in the V3. There's now, they've added a withdrawal fee, an optional withdrawal fee. So you set up the pool, you could have a withdrawal fee. So on the Origin protocol, on our pools, we actually have a withdrawal fee. And those fees can be static or dynamic. So I don't know, you could have something dynamic based on volume, or I don't know, based on stake tokens or something. I don't know, you could come up with all sorts of stuff there. I've talked about swap withdrawal fee. Okay, now the other big change in here is they've got one big singleton contract. So all these swap contracts are going to be in this one massive contract. So all the assets are going to be sitting in this one contract. So there's no, so all these examples where you're transferring these tokens around goes away. So you're going to have this one big honeypot with a lot of assets in there. They're going back and using native F transfers like V1, so no more WrapD. They're all about trying to do gas savings, and I can't remember what donate liquidity is. I did these slides on the weekend. Yes.
So each of these features are very unique. Right? So they get initiated when the pool is created, and
Yeah.
they can't be changed.
I presume they can't be changed. I haven't actually looked that far.
Sorry, can you repeat the question?
So there's features here. So assume like if you customize, if you put a hook on the swap hook, can that hook be changed? I'm not too sure, but that hook could call a proxy, which could be changed. So you could change it indirectly.
I mean, it has to be, right? Because like, whereas who's changing the LP token vote maybe?
Yeah, well, that's going to be like auditing this stuff. Like, it's not like you can go, oh, it's just Uniswap, I can use it. Like using these custom things, like, yeah, these could be, you know, you could customize a rug function in here and just pull the whole thing, you know. So you've got to, yeah, there's got to be careful. Yeah, like the swap could just like give you really bad pricing or something. Okay. Yeah, as I mentioned before, we had one big singleton contract which talks all token contracts. So yeah, it's just internal accounting. There's no actual transfer. So yeah, there's going to be highly gas optimized, and even the hooks are highly gas optimized. But yeah, you have a look at this contract on ETHScan when it's launched. It's going to be massive. Did I mention that? No. Okay. All right. The other important thing in here is so you can't actually deploy these yet, V4, because it's using transient storage. So it's a new feature in the next release of Ethereum, in the Dunkun or whatever it's called. And I can't remember the EIP, 11 something. So basically, transient storage is like a new storage class for in transaction memory. So it's much cheaper. So you can, a classic example is the re-entry protection. So at the moment, you know, if I'm the swap contract, Ron calls me, I'll persist into the storage and say, okay, I've got a record. Ron's called me, and you know, no one else can come back in. But that writing to storage in the smart contract's expensive. But with transient storage, it's much cheaper. So, and it's only available for the period of the transaction. So once the transaction's over, that storage is gone.
Do you think the gas will be cheaper than B2?
Overall, the transactions, yes, yeah. The gas usage on the swaps is way cheaper.
B4,
Yeah, V4, yes, because it doesn't have to do all the token transfers.
like a 10th of B2? Or?
Well, I think I saw something they said like 90% cheaper on token transfers, but I don't know about all the other bits. Like some things, like some tokens are really expensive. I had some examples in here, like just getting a token balance, for example, can cost like 10,000 gas for USDC because it's going through, because it's proxied and it goes and looks up storage and does stuff. So some tokens are expensive. Other tokens are, you know, they're not proxied, so they don't have, you know, they don't have to route, are much cheaper. But yeah, all that goes away in here because it's all just accounting in this one contract. Cool. That's probably long enough. Any other questions? Otherwise, we'll do. Yeah.
So you mentioned that you're using like to visualize.
Yes.
And then I was wondering, so I'm looking currently data, try to understand it a bit more.
Yeah,
and I wonder if you could use that tool to kind of visualize those transactions as well.
Yes, you can. Yeah, it's called TX2 plus the number 2 UML. So transactions to UML. Yeah. So it does value transfers, which is these diagrams. So it'll generate these, and it'll actually generate like this is actually just generated straight from the tool. So it actually uses the EtherScan labels, and I'll look up any token symbols, etc. So this is pretty much out of the box. And then the call diagrams, it can do, it'll generate all that for you. The trouble is trying to find examples. So I actually spent quite a bit of time trying to find examples of where there was like a flash swap, etc. So for that, I used June Analytics to try and do a lot of the analytics and trying to find examples. Yeah.
So I haven't looked at ETHSydney before, but in terms of the rules and like how you construct them, is there any like standardization around like how they, for example, use like token volume trade? Does that rely on a developer to code that other data structure?
Yeah. No, it's on chain, but yeah, it's, those hooks are effectively calling a custom function by a third party developer, yeah, which Uniswap will have no control over. So yeah, the audit of these things, you're going to use a particular pool, you want to make sure it's not just audited the Uniswap bit, the hooks are not doing anything dangerous as well. And I think the hooks themselves, I haven't looked into it, but yeah, they've got some like tricky gas saving bits in there. Like you've got to generate your transactions so they start with certain, like they're using the bits at the start of the address to dictate what type of hook from memory. So yeah, they're really gas optimizing this. Cool. We're doing shout outs. Yeah. Or maybe I can do it. So yeah, so in the past ETHSydney events, there was a bit where you could stand up and do a shout out if you've got working on a particular project, you're looking to hire someone, you're looking to be hired, you're interested in something. So yeah, like 1 minute, 2 minute max. Anyone got any information or projects or anything they want to share? Yeah, Rob.
Yeah, so I've got a position. It would be it's a research assistant on a research grant that's looking at applying a verification tool with the UNSW to things that include consensus protocols. So what I'm looking for is ideally somebody who's sort of got a computer science degree and is strong in theoretical aspects of computer science, but not take people who've got mathematics backgrounds as well. But sort of typically I'd be looking at appointing somebody with an honors degree or upwards.
Very good. Anyone else? Yep.
Yeah, so I launched a global cryptocurrency exchange called Context. It's a swap platform and a trading platform combined into one. I launched this swap platform in May 2021. That was my prototype. I've been working on it for about 2.5 years now. Yeah, finally launched it 2 weeks ago. So I'm looking to grow that. I'm trying to see funding so I can grow the business.
MONDX.
Sorry.
What's it called again?
Context.
Context.
So, yeah, QUANTX. It's mycontext.com is the website. You can check it out.
Excellent. Anyone else? Yeah.
I built a project called Verity DAO. So basically it's the blue decentralized checkmark for any smart contract on Ethereum or any Ethereum-based chain, the L2s. Basically uses humans to authenticate any contract and provide a library to various NFT marketplaces, decentralized exchanges like the wallets. So like go on OpenSea, you see an NFT with a blue check mark that's gone through OpenSea's verification process. And any other NFT marketplace would have to do the same kind of thing. So it's all very siloed and resource intensive. So the idea is to remove all that, create a standardized process for that check mark and distribute across any platform or product for free.
What's it called again?
Verity DAO, so VERITIDAO.com. So it's on early testnet, so it's ready for testing and approval feedback. If anyone's interested,
Yeah, we have one smart contract of service. Who comes last?
Who's we?
Yeah,
Yeah. Cool. Awesome. Anyone else? Yep.
I'm just building some June analytics dashboard. So if people are interested to get some dashboard built, you can talk to me.
Wizard.
Yeah.
Anyone else? I'll do one because he's too shy. So Liam there is looking for work experience. He's in year 10, Python developers. What else? A number of different languages. He's actually building like a machine learning one to learn how to lip read. So he knows his stuff. But yeah, anyone's looking for an intern or someone to do some work experience.
And that's why I did 5 years ago the blog on where
Yes, that's right. They've been doing this for a while. Anyone else? Yeah.
So I'm newly a lecturer at UNSW in the finance side, but I teach the DeFi course. So if anyone was sort of interested in kind of guest lecturer or even wants to partner with some research I'm doing on MEV on Uniswap,
Yeah, okay.
other stuff.
Cool. Is that an undergraduate or postgraduate? Both, yeah. Anyone else? No, all right, we'll have a networking break now and then we'll get into the chat. Chat day, so. Oh, yeah. Bob, should I kill?
I'm guessing you just left.
Okay, yeah.
Stop and leave the conference.
Yeah, okay.
Yes.